Lessons also on limits. Today we're going to focus on what the idea is of a one-sided limit compared to a two-sided limit. So far, the last lesson, we looked at a two-sided limit, meaning that we looked from the right and left to make sure it was approaching the same value on both sides of the x value we were looking at. But sometimes you're asked for a limit, and all you have to do is look at one side of it. So I want you to look here. I'm not going to look at the mathematical definitions too much. Know the limit notation. What makes this one-sided, what you'll notice is that there's a minus sign. Do you see that in the limit notation? That means left. Or there's a plus sign with the limit notation. That means from the right. So let's look off the graph. It's already been graphed for you. We're going to go to Desmos when we need to here. So from the left, so that means take and trace the graph going left. So from the left going to your x value. So I'm going to go to 2. So from the left going to 2, what's the y value that it's approaching one-sided? And I want you to know the y value there is -1. But from the right, so if I side, well, the y coordinate from the right is +1. I want you to notice that the limit doesn't exist there because they don't agree and there's a jump. But if we make a one-sided limit, then it does exist because we're only looking at one side of it, not both sides. All right, that's the work we're going to do today. And if we need to go to Desmos, we will to graph it to see what the values are. So here we have a piecewise. We have -x subtract 5, 2x subtract 1. What's the value as x approaches -3 from the left? So from the left, if I look carefully with the piecewise, left means less than -3. So I just need to plug it into the top piece only. So where there's an x, plug in -3. Be careful. You have a negative and another negative. So that's +3 subtract 5, so that answer is -2. On the other one, it's the plus sign. So that's the one from the right, and that's going to be the bottom piece. So plug -3 into the bottom piece, and you get the answer -7. Look at number 2. Again, at 0, it splits into two pieces. So you have one piece up to 0 and another piece bigger than 0. And the limit is talking about what's happening at 0. I want you to notice if the x value here was not where it breaks up. So let's say it says x approaches -5. I would only need to plug it into where it's valid. Here we have a jump or a split, maybe. So because it's where the two pieces break off when x is 0, we have to look at that. Now from the left, I'm going to plug it into the top. So when I plug in 0 to the top, I get the answer 1. If I plug in 0 on the bottom, I get the answer -5 for the limit. Now, some of these I'm going to need a graph to help me out here. So 5x plus 10, and then x plus 2, and then what's happening at -2? So if I just plug in -2, I'm going to not get an answer. It's going to be undefined. So I'm going to go to my graph, and I'm going to type that in. So I'm going to type in f at x equals, and it's rational, 5x plus 10. And then in the denominator is absolute value of x plus 2. And I want to know what's happening at -2. So let's look carefully to see what's happening at -2. So first of all, what does it mean from the left? That's this piece down here. It's from the left coming to -2. So let's look at it. As it gets closer to -2, what's the y value that it's approaching? So can you see what the y value is here? And you can see the y value here at -2 is, I don't know why there's a little jet of a vertical line here. There shouldn't be. That's a fault in Desmos. It actually is only a horizontal line that goes to here, and there's no little piece that kind of jets up. I just want you to notice what the y value is there. And can you see the y value is -5? So from the left, the y coordinate is -5. If I, oops, I didn't mean to zoom in there. If I look here from the right, what's that? Look at the y-coordinate. It never changes. What's the y-coordinate as it gets closer to negative 2 from the right? And I want you to notice that answer is positive 5. All right, we're going to stay here on Desmos for the next question. So this is what it looks like. Negative 5 and positive 5 from off the graph. The next one, we have a negative, we have fraction, x plus 2, and then x squared plus x subtract 2. All right, so type it in. I want to know what's happening at 1. So at 1, I want you to know there's an asymptote right here at 1. One side goes up, the other side goes down. Now, what's happening only on the left? Well, on the left, it goes up. So an answer we can give to the limit on the left is infinity. Remember, you could also write down the word does not exist, because is it ever possible to approach infinity? And then what's happening on the right side is it's going to negative infinity. So we're going to write the answers infinity and negative infinity, but you could also write down the answer does not exist when the limit is approaching infinity. All right, number 5. X plus 1 and then in the denominator is negative x subtract 4. So what's happening as x approaches negative 4 from the left and from the right? So you can see where negative 4 is. There's an asymptote here. On the left, where's the graph going? It's going down. So the limit to the left is negative infinity. To the right, where's the graph going? It's going up to positive infinity. Number 6. It's just secant x. And then what's happening at pi over 2? I wonder what would happen if I change my it's going to change the x value from 0 to pi. I want to see if this works. And then I'll change the step to pi over 2. And then I'll get out of this, and I'm going to see what's happening around pi over 2. So where's the graph again? Oh, it erased. So f at x equals secant x. So do you see at pi over 2? And I press the wrench to change the scale. Remember, this is what the scale looks like. So I just changed the x. Notice it changed from negative 10 to positive 10. It's really the step that I was looking at. So if I change the step, then I can actually see the scale in terms of radians. So let's get out of that. So what's happening at pi over 2? From the left, it's going up at pi over 2. And then from the right, it's going down. So if I look at pi over 2, the left side is going up and the right side is going down. So here are the solutions I have for this so far in terms of understanding the right side compared to the left side. All right, turn the page. So we're going to continue to practice this. If I need to graph, I will. In fact, so most of it's going to be on Desmos that I'm going to look at. So here, I'm just going to go and keep on Desmos as I type it in. So I have x squared subtract 6x plus 8. In the denominator, I have x subtract 2. And I'm going to change the scale here, so it's not pi over 2. So I'll just change the scale to 1. Oops. So I can see it better. So there's my scale at 1. And I want to know at 2 what's happening. So at positive 2, from the left and from the right. They agree, by the way. So they're not going in different directions. Notice exactly at positive 2 it's undefined. But what's the y-coordinate? And notice that from the left and from the right, it exists both ways. So we can just write down the answer here is 2. Notice in the question it does not have a little plus sign or a little negative sign. So it's something to be aware of. So in number 7, notice the limit notation. There's no little plus sign or little negative sign. So that's just a two-sided or a standard limit. Oh, did I write down positive 2? I think I meant to write down negative 2. So at positive 2, what's the y value? And the y value is negative 2 there. Excellent. All right, number 8. I'm just going to type it in. Oh, it's the same one, except the denominator is, no, it's x squared subtract x. Looked almost like the same one. So x squared subtract x subtract 6. In the denominator is 4x plus 4. And what I'm looking for is at negative 1 and the right side at negative 1. So I want you to see where negative 1 is. On the left, it's going up. But where's the right going? And the right side is going to negative infinity. And again, you could write down the answer does not exist. But we're going to write down infinity or negative infinity if that's the answer. Number 9. We're going to write down x cubed plus 4x squared so x cubed plus 4x squared, and then in the denominator x cubed plus 7x squared plus 12x. All right, and then when I look, what I'm looking for is as x approaches negative 4. So if I look at negative 4, I want you to notice that there's no asymptote there, but there is a hole there. So do you see? Oh, it slid on me a bit there. So there's the hole at negative 4. And what's the y coordinate? So just look at the y coordinate of that hole to give you the answer. And the answer is 4. And the right and the left both approach the same y coordinate, so it exists. All right, next one. X squared subtract x subtract 2. In the denominator, x squared subtract 2x subtract 3. And what's happening at 3 at that time? So do you see at 3 we have an asymptote? It says it doesn't have a plus or minus sign on the limit. So on one side it goes up forever, and on the other side it goes down forever. So for number 10, the answer is does not exist, because they're asking for a double-sided limit, not a single or one-sided limit. So if you have a two-sided limit compared to a one-sided limit. So in this question, it asks for a two-sided limit, and it doesn't exist. If it had a little minus or plus sign, then we could put down the answer infinity or negative infinity. All right, number 11. So first of all, recognize it's a one-sided limit. X plus 2 over x. Oops, I should have done the fraction line at the beginning. So x plus 2 over x. What's happening at 0? So at 0, we have an asymptote, and it has a little minus sign. So from the left, where is the graph going? So I want you to notice the graph is going to negative infinity. Number 12. Can you find that limit? So again, we're going to type it in together. That's 1, and that's x squared subtract 2x plus 1. And it says as x approaches 1 for this one. So I want you to notice again, at 1, there's an asymptote. Notice it's a two-sided limit. Both left and right are going in the same direction. So we can write down the answer for number 12, that the limit does exist, and the answer is infinity. So those are my solutions so far. Number 13. All right, let's write this down. I'm going to do 13 and 14, and then I think I'm going to do a second video. Maybe you can take a little break after 14 and then come back to 15. But let's do 13 and 14. So again, off Desmos, I'm going to type in 2, divide sign, and then in the denominator 3x cubed. So what I'm looking for is at 0. So at 0, there's an asymptote. But what's happening to the right side? And you can see the right side goes to infinity. All right, one more for this video, and then I'll do a second video for the second part. So we have negative 1 over x minus 5. So this might be a good time to take a break after this one. So negative 1 over x to the 5. So again, at 0, you can see there's an asymptote. And it's a two-sided limit. There's no little plus or minus sign here. So at 0, what's happening? I want you to notice the left side goes up forever and the right side goes down forever. So therefore, for this answer, it does not exist for number 14. So let me just show you again the solutions here. Off the graph, we were getting these answers. Again, be aware if you have a little plus sign or minus sign, that will change what you're looking for. And Mr. G Math, over and out. And until next time, and we're going to be doing the rest of this lesson on the next video.